All right, today we're going to move on a little bit from properties of exponents and move more towards rational exponents and how they relate to radicals. And rational is another word for fractional, so we're in fractional exponents right now. There's a relationship between a rational exponent and a radical, and you'll notice that this relationship is pictured here. So when you have a rational exponent here, a over b, that can be converted into a radical form by leaving the numerator of the fraction as the exponent of the base, but moving the denominator of the fraction to become the index. That's why it's a raised number here at the corner of the radical, become the index of the radical symbol that you place around it, okay? So we're going to practice that little switch here at the very beginning, and then we'll apply some of that in a little bit. So first of all, the first thing I'm going to do here is I'm going to convert from a radical to a rational exponent. That's going to be x to the 7 over 4 power. That is a 1. Get in the habit of recognizing that. So that's x to the 1/4 power. Now, what happens when the index is not written? Usually that's a 0 or a 1 in mathematics, but this is one of the few times when it's not 0 or 1. And remember, it's a square root, and when we square something, it's going to be a 2. So when you see a radical without an index, it is a 2. So that's going to be x to the 5/2 power. That's going to be 16 to the 1/2 power, because there's a 1 there. For some reason, we get tripped up a lot about numbers to the 1/2 power. That's the square root. So for simplifying this down, that's clearly 4, okay? So just recognize that 1/2 is the square root of something. So now what I've got is a switch in the other direction. The switch in the other direction is going to give me a radical, so I'm going to draw that first. The numerator stays on as an exponent, and the denominator becomes the index. That's why it's raised at the corner. So again, I'm going to make the radical symbol first, and that's going to be 100 to the 1st power. And I'm going to put the 2 there, but remember, it's not necessary because it's understood that that's a square root. And of course, that's going to be 10. Now I have a nonsensical thing here that's going to just see if you guys can understand how to actually apply this properly. The asterisk or the star stays put. I'm going to draw my radical symbol, and W becomes the index of my radical. The next thing we're going to do is we're going to use properties to simplify these radicals more thoroughly, okay? And now what we're going to have here is the cubic root of -8 to the 1st power. Well, if I rewrite -8 as the same number 3 times, which is something we can get into the habit of doing here, it kind of helps us see how to do this. So I get -2 times -2 times -2. So it kind of goes back to that tree diagram we were doing before, where you'd break this number down and then simplify it. Well, remember before we were just using square roots. Now we're going to be using different index numbers. So you're going to have to circle this many, or you're going to have to find a perfect cube this time. And so since I have 3 of them, they come out as a single number. That's going to be -2. Now for these ones, it's clearly simple that you can do that, but I want to go through this process so you understand what you're looking at here, okay? Now because negative times a negative times a negative is still a negative, that's why the resulting number is -2. I'm going to switch that over, and I get the square root of 121 to the -1 power. All right, so let's begin with the square root of 121. Remember, it's properties of exponents, so it doesn't matter which exponent I do first, it's all going to turn out the same way. So it's going to be 11 to the -1 power. Well, now I have to remember properties of exponents here, and if I have a negative exponent, I have to move this entire number to the denominator of the fraction. So I have to create a fraction, and the answer to that is 1 over 11. All right, this one is going to be the 4th root of -16. All right, so if the index was even, that means it's going to have a non-real solution. So that means it's going to be the fourth root of I, and then I'm going to break 16 down into 2 times 2 times 2 times 2. And that's going to give me my group of 4, so that's going to be 2I. Next thing I'm going to do here is I'm going to break this down as the third root of 8 squared. Okay, now it doesn't matter which one I do first, it's still going to turn out the same way. Okay, so let's go ahead, since I did this as the radical first, I'll do the opposite here. So we're going to get the third root of 64, because that's what 8 squared is. Now I want to break down 64 into a perfect cube. Well, that's 4 times 4 times 4, and that's going to give me the answer of 4. All right, moving here, we're going to take a look at this in terms of a large radical, where it's the square root of 4x to the third power. Well, from that, it's 64, so it's going to be the square root of 64x to the 6th. Okay? Next thing I'm going to do is I'm going to break this down. We just know that's going to be 8 and 8, and that's 1, 2, 3, 4, 5, 6. So I'm going to circle my groups of 2, and that's going to be 8x to the third power because I circled 3 groups of 2x's. Let's switch this. Well, it's already ready for me, so I'm just going to go ahead and address this one first. So the cube root of 27 is 9, and 9 squared is, sorry, let's fix that, shall we? The cubed root of 27 is 3, and 3 squared is 9. All right? Question number 14. Now we're getting back into those properties there where we have some negatives, so let's be very careful about that. The cubic root of 125 to the negative 2 power. All right, so cubic root of 125 is 5, so I get 5 to the negative 2 power. So that means with the negative property, I'm going to change this to 1 over 5 squared, and 5 squared is 25, so the answer to this question is 1/25. All right, now we're involving a lot more details here that we need to be careful of. So I have exponents and then I have a radical. So let's get it all in the same terms. So I get r squared t to the third divided by t to the 4/3 power. Let's fix that. Sorry, that's 3/4 power. 3/4 power. The r just stays put, but the t's can combine by using subtraction. So I'm going to do 9/12 over 4, because that's what 3 is, with a common denominator of 4. So I'll just rewrite that. 3 equals 12 over 4. And then I'm going to subtract 3/4 from that, which will give me 9/4. So my final result here is r squared times t to the 9/4 power, because the larger number 3 is on top. That's why the t remains there as well. All right, I've been doing a lot of work, and I want numbers 16, 17, 18, and 19 all to be work that you do. We're going to talk about these tomorrow, see how well you can combine properties of exponents with simplifying radical exponents or rational exponents or radicals. Okay, so have these 4 problems ready to go. Discuss with your group mates tomorrow so that you're ready for any collaboration that we need to do here.